So class, this will be the first video starting chapter 5. And so we'll get right into chapter 5, which is systems of linear equations. So just as a quick refresher on what linear equations just means a straight line. And if we have a system of linear equations, meaning we have more than one. So I have here on just a little warm up, determine the number of solutions. So for the first graph here on the left, I have two lines, 2x minus y equals 2, and x plus 2 equals a negative 2. The number of solutions, the solution is just going to be where they intersect. So this would just be one solution. Now for the middle graph, each of those will have the same slope. So each of these actually have a slope of negative 3, and so they will never cross each other. So this one would be no solution. The third graph, x minus y equals a negative 3, and then 2x minus 2y equals a negative 6. Well, we can see that the second one is just a multiple of 2. And so these are actually the same line. These will lie exactly on top of each other. So I only have one line here in the graph, but it's because they're lying exactly on top of each other. This is infinitely many solutions. Any x value on there will get the exact same y value. So there's infinitely many solutions for that one. So solving a systems of equations. First thing we're going to talk about is substitution method, where we literally solve one equation for a specific variable and then substitute that in. So if I had 3x plus 2y equals 11, negative x plus y equals 3, I could rewrite one of these equations to substitute into the other. So I'm just going to pick this bottom one because this would be an easy one. If I add x to each side, y is going to be equal to x plus 3. Now I'm going to take that y and put it in here. So 3x plus 2 times x plus 3 equals 11. Now I have one equation with one unknown, and I can solve from here. So if I were to solve this, so 3x plus 2x plus 6 equals 11. So 5x plus 6 equals 11. If I were to subtract 6, I end up with 5x is equal to 5. So therefore, x is just going to be 1. Well, I want to figure out what x is and what y is. Well, if I know x is 1, I could substitute in. This one's pretty easy to substitute into. If I want to find y, I know my x is 1 plus 3. That means y is equal to 4. So to solve this system of equations, the only place that these two lines would intersect would be at the point 1 comma 4 is where these two would intersect. Another way I can look at solving is using elimination. So elimination, you want to make sure first off that your x and y's are stacked on top of each other. If it's written as y and then x, just move things around so that you get your x and y stacked on top of each other. And what I want to do, I want to figure out a way to make these be the same values, same coefficients for the x's or the same coefficients for the y's to be able to eliminate. And they have to be opposite signs if I'm actually going to eliminate, because I want to be able to add these up and get 0 somewhere on here. Well, 0 specifically somewhere on the x or somewhere on the y. Well, right now I can't do that, but I can manipulate each equation to change it up. So let's focus on the 3 and the 2. I'm going to make the top equation, instead of being 3x, I want to make that 6x. In order to do that, I have to multiply by 2. So I'm going to multiply every single value in here by 2. So now this becomes 6x minus 8y equals 2. Do not forget the piece that doesn't have a coefficient with it. You have to multiply that by 2. The bottom one now, I'm trying to get that negative 6x, so I'm going to multiply by negative 3. So this becomes now a negative 6x minus 9y is going to be equal to a negative 36. Still have my x's and y's stacked on top of each other, but now when I add these, I get 0x. So I've eliminated my x. When I add up -8 and -9, I end up with a -17y, and then I'll end up with a -34. Solving this, divide by -17, divide by -17 is going to end up with y is equal to a +2. So I figured out y. Now I need to figure out what x is. So I can put this back into any of my equations. Let's just pick, I'll pick this top one, 3x minus 4y equals 1. So 3x minus 4y, well, I know my y is 2, equals 1. So 3x minus 8 equals 1. If I were to add 8, I end up with 3x equals 9. Divide by 3, I end up with x equals 3. So where these two intersect, their solution is going to be 3, 2 is the solution to this system of equations. Now let's solve with any method. If we had 3x minus 2y equals 4, -6x plus 4y equals 7. So this one I'd probably do with elimination because this is an easy one. If I multiply by 2 on the top, I end up with 6x minus 2y, multiply by 2, so 6x minus 4y equals 8. And then I still have my -6x plus 4y equals 7 for my second equation. So now again, I want to add these up to eliminate. Well, if I add up 6 and -6, that becomes 0x. -4 and a +4 becomes 0y. 8 and 7 becomes 15. So what I ended up with is 0 equals 15, which is false. That is not a true equation. So this one, there would be no solution. This is what's called an inconsistent system. All right, so this one, there would be no intersection on this. Okay, this is no solution. It's an inconsistent system. You can look at another one. 8x minus 2y equals -4. -4x plus y equals 2. So this one would be an easy one. I'm going to multiply by 2 and use elimination. So 8x minus 2y equals a -4. And this would be a -8x plus 2y equals now 4. This one I get 0x. I end up with 0y equals 0. But what this is saying is 0 equals 0. This is true. 0 does equal 0, so this one is true. This is a consistent system, and this one will have infinitely many solutions. Okay, so just because we end up with 0 equaling 0, that is beneficial. That does tell us that it's an infinitely many solution. It's where the lines lie directly on top of each other from the warm-up. So take a look at 5.1 in Math Excel. This is actually going to be part 1. We're going to have a couple more videos for 5.1. Due Sunday, 3/29 by midnight. As always, if you have any questions, send me an email and keep working through these problems on Math Excel.